All right, let's dive right in. We're going to talk about something that's absolutely fundamental for managing Cisco's application-centric infrastructure, and that's how to monitor it using the simple network management protocol. You know, good old SNMP.
So let's kick things off with a question that I think every network admin managing a modern data center has to ask. You've got this incredibly powerful, policy-driven fabric, but how are you actually keeping an eye on its health? How do you know what's really going on under the hood?
Now, ACI has this amazing API, right? It's fantastic for automation. You can pull basically anything you want from it. But sometimes you just need a reliable, universal, tried-and-true method to check on system health. And that's exactly where SNMP shines. It gives you that direct line into critical performance data.
Okay, so here's our game plan for today. We'll start with the why. You know, why even bother with SNMP and ACI? Then we're going to get hands-on and walk through creating a policy, setting up trap destinations and sources, and then we'll wrap up with a look at some really cool advanced monitoring using contexts.
All right, first things first. In a world of APIs and advanced telemetry, why are we still talking about SNMP in a super modern fabric like ACI? What's the deal? Well, at the end of the day, it's all about those essential health checks. You can remotely pull your leaf switches, your spines, even the API controllers themselves to see if CPU's spiking or if memory's getting tight. And ACI supports all the flavors you'd expect, including the much more secure SNMP v3. Now, there is one really important thing to remember. ACI's implementation is read-only. You can pull for data, you can receive alerts or traps, but you cannot use SNMP set commands to change the configuration. For that, you use the API.
So if there's one thing to get right from the start, it's this. The whole configuration is built on three main, let's call them building blocks. You've got the SNMP policy, which defines how the fabric can be monitored. Then the trap destination, which defines where alerts get sent. And finally, the trap source, which is the glue that defines what gets monitored and ties it all together. We're going to build each one of these, step by step.
Okay, let's get our hands dirty. First up is our first major task, creating that SNMP policy. This is really the foundation for everything else we're going to do.
And don't worry, we're going to follow a super simple four-step process right inside the APIC GUI. We'll just navigate over to Fabric Policies, create the new SNMP policy object, and then this is the important part, we define all the details, like our access credentials. And to finish it off, we'll associate that policy with a pod policy group to actually make it live.
And here it is. This screen. This is basically mission control for your policy. In this Create SNMP Policy dialog, you're going to define everything, your V2C community strings, your more secure V3 users, and, critically, which network management stations are even allowed to talk to the fabric. So let's just quickly break down these key fields. Community policies, that's for your standard V2C read-only strings. Then for SNMP3, you'll create users with their specific authentication and privacy settings. And this is super important. Under Client Group Policies, you create a whitelist. You put in the IP addresses of your monitoring servers, and that ensures only authorized systems can query your fabric. Now, here's a classic ACI thing to remember. Just creating the policy doesn't actually do anything. To bring it to life, you have to attach it to something called a pod policy group, which itself gets applied to a pod profile. It's ACI's way of connecting an abstract rule to the real physical hardware in your data center. Okay, so our policy is built, we've defined the how, now we need to tell ACI where to send alerts, or traps, when something interesting happens in the fabric.
And it makes perfect sense, right? This part of the config is under the Admin tab, because your network management system is an external data collector. The process is pretty straightforward. You create a destination group, you can even put multiple servers in there, and then you add your specific trap destination details into that group.
And this screenshot shows you exactly what that looks like. It's a pretty simple dialog, where you just plug in the IP address or the host name for your NMS, you make sure the port is right, and you pick which SNMP version that server is expecting to see.
Okay, pay attention to this next part, because it's a super common gotcha that can trip people up. See that security name field? It does double duty. If you're using SNMP v2c, that's where you put your community string. But if you're using the more secure SNMP v3, that's where you put the username that you created back in the main SNMP policy.
All right, we're almost there. We have our how and we have our where. Now it's time to connect them with the final piece of the puzzle, the SNMP source. This is the what. Think of the SNMP source as the glue that holds this whole thing together. It's what connects all the dots. It basically says, hey Fabric,
For this set of things you're monitoring, I want you to send any alerts to this specific destination group we just built.
And you know what? The actual configuration here is about as easy as it gets. You just pop over to the monitoring policies, create a new SNMP source, give it a name, and then you just pick your destination group from a drop-down list. You're literally just linking two things together. It's that simple. Okay, so we've got the fundamentals down, but now let's get into a really cool advanced feature that's an absolute game changer if you're running a multi-tenant environment.
This right here is one of my favorite things about SNMP and ACI. Each and every tenant's VRF gets its own separate, isolated management information base, or MIB. A MIB is just a database of stats you can query. This means you can pull for something like BGP peer status completely inside tenant A's world without ever seeing a single piece of data from tenant B. It's true multi-tenant monitoring.
So let's look at a real-world example. Here's a pretty standard SNMP walk command you might run. We're using the community string Cisco1 to walk the interface table. This gives you a global, fabric-wide view of all the interfaces.
But now, check this out. Look at the difference in this command. To get inside a specific tenant's VRF, all we do is append the context name to the community string using that little @ symbol. Here, we're targeting a context named SNMP T2 context2 to get BGP info for that tenant and that tenant alone.
So when you boil it all down, the magic is all in how you format that community string. A simple string like Cisco1 gets you the global data, but using the community @context format that lets you dive deep and target a specific routing instance inside your ACI fabric. It's a beautifully simple but incredibly powerful trick.
Phew. Okay, that was a lot, I know. Let's take a second and just quickly recap the big ideas, the core concepts we've covered.
So just remember these key pieces. It all starts with the policy. That's your how, your access rules. Then you define the destination. That's your where, your NMS server. You use the source as the glue to link a monitoring policy to that destination. And finally, you leverage the SNMP context to get that really powerful targeted per tenant visibility. So there you have it. You've now got all the tools you need to pull incredibly detailed monitoring data from every corner of your ACI fabric, from the global level right down to a specific tenant's routing table. But here's the real question. Now that you can get all this data, what are you going to do with it? How are you going to turn all that raw information into actionable insight? That's where the real magic begins.